Welcome, everybody, to the sixth ShareIT event. I am Vanessa Fumicona. I am a dev, and I work for ThoughtWorks Italy, and I used to work for ThoughtWorks UK. So you might know about ThoughtWorks because we're a global consultancy. As you can see, we have multiple offices in multiple countries. But one of the key reasons why I hope you know about ThoughtWorks is because we really like to share knowledge. And you might be familiar with some of the books that my colleagues have written, or you might be familiar with them through seeing talks in conferences or the Tech Radar. And this is very much at the core of what we do at ThoughtWorks. We do enjoy sharing knowledge and experience, and that's from that idea, from that culture, is where this community, ShareIT, was born. So as you can see, ShareIT is a community that was born in ThoughtWorks Italy. All the admins are from this office, but our intent is larger. So our intent is to empower individuals and organizations and to contribute to the community through knowledge share and any of our experiences. And the way we do it is through organizing these events. We try and do it monthly. Sometimes it might skip, it might be a little bit different. And what we try and do is to have a very diverse range of topics so that you can have a feel of the different topics and things that we would find interesting or that we do in our daily jobs. So this could be considered the boring part. We really care within this community and in ThoughtWorks to try and be respectful with each other. And we want to grow this community in a direction that it is healthy and growing for everyone. So you can see that what we ask is to try and be excellent to each other. We want to make sure that you feel that all of your questions are valid. So please feel free to ask anything you want. In particular, in this talk, Kief will take questions at the end, and please write your questions in the Q&A. But feel free to have conversations in the chat like that. We welcome, but we ask you, you see the second point, to try and be kind and respectful to each other. And then the third point is more of a mindset that we want to encourage. We want to encourage a learning mindset where we're all here to learn something from each other, and we're open to that conversation. So I will leave you now to a much more interesting conversation with Kief Forrest, talking about scaling infrastructure as code, and I'll talk to you a little bit later. Thank you, and I'll hand over to Kief.
Thanks, Vanessa. Vanessa and I, we were just talking beforehand that we worked together on her first project at ThoughtWorks here in London some years ago now. It's been a little while.
5 years ago.
5 years ago. So yeah, it's great to be to see you kind of running these events and inviting me to come and talk to you all. I think also Vanessa will share at the end details of where to get like the recording and the slides as well. We'll share the slides. There's a few links that might be interesting and just as a reference. So I'm going to talk today about scaling infrastructure as code. So I wrote the book Infrastructure as Code, which is different kind of patterns and practices for working with different tools. So it's ideas that work across whether it's Terraform or CloudFormation or other tools, and also different cloud platforms, whether it's AWS, Google Cloud Azure, or even there are things that you can apply in your data center if you're running servers in there, how you can kind of do automation with those. But today I'm going to talk particularly about how to handle architectural approaches to kind of larger scale in terms of teams and the number of people working with infrastructure. So I'll start with this, one of my favorite little memes here. Yeah, we're moving to cloud. There's a typical organization says we're going to start using cloud and this will solve all of our infrastructure problems. And so we think, oh, we're going to improve how we manage our infrastructure because we're using cloud. But actually, no, we're not. A lot of organizations just end up using cloud in the same way that they used infrastructure in the data center, which is really losing a lot of the benefits. So let's step back and think about, why do we use infrastructure? What does it do for us? It enables the delivery of value, and it does that through applications and products and the things that run on top of our infrastructure. So that's why we have infrastructure, to be enabling the delivery of value. But oftentimes it's seen as a blocker or an impediment that gets in the way, that slows things down, that makes things difficult for application teams, whether it's developers or support or so on. The idea of cloud is that it can help remove those kind of frictions and those blockers and make it easier so we can automatically provision infrastructure very quickly instead of needing to raise tickets to ask people to buy hardware and those kinds of things. So it should make things much easier, but it doesn't always. And especially for larger organizations where there are multiple teams and many people who are working with infrastructure and using it and maybe building stuff with the infrastructure, it gets very messy and very uncoordinated. And I'll talk a little bit about what some of the problems are that come up. Well, overall, the challenges that we have with infrastructure in general is that the time to market can be quite slow, right? It can take us a long time to have to wait for infrastructure to be provisioned or to be making configuration changes to operating systems or any of these kinds of things. Often slow down, whether it's adding new products and applications or adding features to them or making fixes. All those kind of things can be slowed down if we're not doing very well with our infrastructure. Change management can be difficult. So it can be both from the point of view of it can be difficult as somebody who wants a change, that the process might be too slow or have too much friction to it, or it could also be from the point of view of there actually is a reason to have a process for change management, which is to make sure that things are being done correctly and following compliance and regulations and these kinds of things. And it can be difficult for a change management process to do that correctly. A big problem with infrastructure is value alignment. So that is, are we spending the money on the things that we should be in terms of infrastructure? So for people who work with infrastructure, oftentimes it's very frustrating that we know that we have technical debt, we have old systems, we have things that need to be done, and it can be very difficult to convince the people who manage the budgets to give us the investment to do those and give us the time to do those things. And that can be very frustrating. And then from the point of view of the people who own those budgets and are spending the money, they're often not very clear. They know we're spending a lot of money on infrastructure, but they don't really understand why. They don't understand what are we getting from it. So this kind of lack of understanding across people who make decisions about investment and the people who are working with infrastructure and know what needs to be done leads to a lot of problems. And then there's the sprawl, that is just having so much different things. And especially in the case with cloud infrastructure, this rapidly becomes out of control where people are creating lots of different things and it's very inconsistent and maybe not managed very well. So scalable infrastructure is an approach I've been kind of talking about to managing and architecting your infrastructure in a way that deals with these challenges. And there's 3 pillars to it. And I'm going to talk about each one of these in more detail. But as an overview first, the first one is thinking about value. And I'll talk about application-driven infrastructure. So building infrastructure based on the needs of applications in order to make sure that we're delivering value and that is understood. Architecturally, the composable infrastructure is an approach to making sure that our infrastructure is built in a way that's loosely coupled so that we can change it more easily. And then finally, evolutionary infrastructure helps us with delivery. It's the idea of making sure that we can make changes to our infrastructure very easily and very safely. So these are the 3 areas I will talk about in more detail. The first one is application-driven infrastructure. And as I said, this is about driving the implementation of our infrastructure by understanding what the workloads, the applications, the products that it enables, what do they need, what are their requirements. So one thing to understand is that cloud is not by itself a complete platform solution. So a lot of times people will think, and managers and organizations will think, we're going to adopt cloud and then we don't have to worry about platform now. We can just give application developers access and they can deploy their applications. But in reality, what the vendors provide and what the cloud solutions provide is just a lot of these kind of resource primitives. It's like a box of Lego parts that we have to assemble ourselves. So Corey Quinn, who maintains the Last Week in AWS newsletter, he wrote an article about that there's 17 different ways to run a container on AWS. And this gives you an idea that there's for even for doing one thing, there's a lot of different ways to do it. What's the right way for the situation? What's the right way for the organization? He also wrote a follow-up article, 17 more ways to run a container on AWS. So yeah, there's a lot going on there. So what we do when we use infrastructure, and we use cloud infrastructure, is we have to assemble those pieces, those Lego parts, into a form that's usable for deploying and running our applications on top of that. So this is a big part of what we use infrastructure as code for. On one extreme, a lot of organizations will take a very siloed approach, very much the way that they may be used to taking from data center based infrastructure. So they have a kind of centralized team which owns the infrastructure, and you need to go to them and ask to have things created on the cloud in order to deploy your applications onto it. And that disempowers application teams. It takes away their ability to kind of get things done quickly. And basically, like I said in the beginning, it means that we're adopting cloud, but we're not getting the benefits from it. On the other extreme, a lot of organizations will just allow developers direct access to do whatever they want with the infrastructure, with no coordination and no help. And so what often then happens is infrastructure gets built in a big mess. It might be fragile, very easy for somebody to make a change that breaks something else, or it can be very expensive because people are running up a lot of expenses, and it's all very unclear. So the goal really is to create platforms collaboratively, so that we're empowering teams, so that everybody's working together in how we build the platforms and how we use it. So it's enabling and empowering rather than disempowering. If you're familiar with the 4 key metrics, this is from the State of the DevOps report, and also in the Accelerate book talks about them. These are metrics which for any kind of platform, I feel are a really useful way to measure the success of the platform. And this is for people who are using it, how easy is it for them to deliver changes to what they're doing? How easy is it to deliver value? So it's not just easy in terms of it being very quick and simple, but it's also the kind of stability and quality, so that changes are that they don't fail, and that we can restore service very quickly. So it's not just about speed, it's about reliability and safety of changes. So the architecture of technology capability is the idea of thinking about these pieces in the middle of how you're assembling what the cloud provides. And the focus should really be on creating rules for collaboration. So it's less about having a master plan that tells everybody this is what you're building and how to build all the details of it, but how do we build things that work well together? The metaphor of city planning and building code is a good one for this. So Eric Dornenberg, who's our head of technology for ThoughtWorks in Germany, he did a talk a while back where he talked about architecture without architects. And he had this town planning, city planning metaphor, which I think is really useful. And this is just the idea that we think about laying out how you're going to build things that will connect together, how infrastructure pieces like, say, for a city, it's like the water supplies and electricity. How do you connect to these things, and what do they provide for you? So by defining these things, focusing on that from an architectural point of view, it helps then to enable, like it tells people, how do we work together? How do we make sure the stuff that we're working will work together well? And how do we decouple changes so that somebody who's working on one part, let's say you're building one capability which defines a Kubernetes cluster, then somebody else is creating a logging system, say. How do you make sure that they work well together so that we can change the implementation of one without accidentally breaking something in the other? So it's defining those boundaries. And that's what I'll talk a little bit more in the next section. But getting into the how do we kind of plan this stuff so that it's driven by the value, and that value is very clear. So as I said at the beginning, the value that infrastructure is delivered through the applications, the business capabilities and products which sit on top of it. So we start with that. We look at what are the things that are running on that need to run on top of this infrastructure, and what do they need? And so we can build kind of a mapping of different applications in our portfolio. What are their different requirements, both from a technical viewpoint, in terms of things like, well, this thing needs Java, this thing will run as a Docker container, this thing needs an Oracle database, but also kind of in terms of other requirements, say non-functional, cross-functional requirements. So things like, what are the security requirements? Are there some capabilities which are handling more sensitive data and so need to deal with, say, privacy regulations and those kinds of things versus other capabilities which might not, or other applications which might not. So understanding that kind of landscape and then understanding the capabilities and the requirements for those capabilities is useful so that we can think about what infrastructure resources will be used to build those capabilities from. And a kind of domain-driven approach can be useful. A lot of what I think we're starting to learn how to do with infrastructure is to bring concepts from application development and application architecture and design into our infrastructure. So the idea of taking domain-driven design and applying this to our infrastructure to think about what are the services and capabilities that the infrastructure is providing, and what are good boundaries for that. And sometimes I think traditionally in infrastructure, a lot of times we've defined things around technology. So we have like a Linux team or a firewall team or a DBA team, whereas really we should be thinking about what are they providing. So it's the capability to run applications, the capability to monitor our applications, these kinds of things. And that might make us think differently about the ownership, say, of teams over different parts of the infrastructure and systems and the ways to kind of group and architect them. So where we want to get to is building a roadmap that crosses our applications and our infrastructure. And actually, one of the first times we did this, or certainly that I did this, was on the project that I worked with Vanessa on. We did this. And the idea was that we looked at the applications and what they need to have and the backlog of stories for those applications and the capabilities that we needed to build in order to support those applications. In our case, it was the delivery. So it was about being able to build pipelines and so on for the applications. So we looked at those capabilities and looked at what is the work that needs to go in order to build out those capabilities. And then we can define outcomes, and those outcomes should be very much top down. So as an example, we might think about the first milestone is that we just need to be able to have tests and have our internal users test the application. And so we can look at what kind of subset, what thin slice of our underlying infrastructure do we need to implement for that. And it might be, for example, for that internal testing, we don't need to worry so much about the privacy of the data and so on, because we're not going to be using real live data at this point. We might not have to worry about scale. Or we might not have to support large numbers of users because there will only be a few users using it at a time. So we can then kind of sequence the implementation to build out the scale that we need later on, so that the second milestone might be where we have a pilot where we're letting some of our customers use it. So we might then need to have implemented the security and the data privacy and those kind of things in order to handle, because we're going to be using real live data at this point. But we still might not need to worry so much about scale, and we might not need to worry so much about, say, recovery. So we might say that if we have a failure to the system, it's okay if it takes us an hour or two to recover, because the people who are using it aren't relying on it. They're still beta test users, so they're not relying on it for critical things. Whereas in the third milestone might be we're going live to our full customer base. It's going to have, again, real data, real transactions, and be business critical. So we have to be able to recover from errors very quickly. And we might need to scale up to a much larger base. And then we say we have later outcomes, which are things like we're going to scale out to other regions and other countries. And so we have to think about how to handle those things. We might be adding new features and functionality for the products, which require more things to be done with the infrastructure. So this gives us a way to make vertical slices and incremental delivery of our infrastructure that's aligned. And so that's very easy to explain to people, what is the value of the infrastructure that we're building? What are we getting from it? So now, in terms of composable infrastructure, in terms of the architecture, our goal here is to build loosely coupled components of our platform. So if we think about this kind of picture that I've shown before of technology capabilities being the pieces in between, we implement these basically by assembling infrastructure resources from the platform. And I keep saying about cloud platform, but this also applies in data centers. We can do the same things in data centers where we're automating how we provision hardware machines or running virtualization and those kind of things underneath. As long as we can provision these things with code, then we can we can do this there as well. So the technology capabilities, if we think about maybe this is a Kubernetes cluster, and so we're providing the ability to deploy containers, deploy and run containers. And so we need different resources underneath. We might need, we might need the Kubernetes service if we're using Kubernetes as a service from the provider, but we might need networking, we might need storage, we might need some other things that we pull together in order to provide a useful thing to those the people who are building and running applications on top of it. And so we do this as code, right? This is what our infrastructure code is doing, is assembling these things in a useful way. Now, the challenge that we run into is that these infrastructure code bases can get very big over time. And so you'll have a lot of different code, a lot of different people working on it, and it can create a lot of problems. So one thing is that changes become slow. It takes a long time to make a change because we have to coordinate a lot with what's going on there. It can be risky because it's very easy to break something. And it can be disruptive where we need to make maybe what should be a small change to one small area of the infrastructure, but we need to coordinate because of all the applications running on top of it. And because we don't know necessarily what the impact is going to be, it means that we have to plan downtime for things that might be small changes. We can also have problems where, because we have lots of people creating infrastructure, there might be inconsistency. So we might have multiple different, going back to that 17 different ways to deploy a container, you might have different teams doing very different things in order to run containers. So there might be overlapping. And we might not have good visibility and control over the costs of all of this infrastructure that people are building, and other operational concerns. So how can we make sure that all of this stuff, everything that's being built is being built well, that it's compliant, and that it meets our criteria for things like security, and for kind of stability and performance and these kinds of things. So the kind of approach for this this capability level of the architecture is to focus on defining interfaces. And so particularly, again, for these larger organizations which have multiple teams, the focus of kind of that cross-cutting, whether it's an architectural group or whoever it is, it's kind of, or a platform team, is to say, let's define what the boundaries and the interfaces are between our capabilities. So if we have this capability which is running a container, which is got the Kubernetes cluster and it's got the networking and storage and it takes underneath there, and then we need to have clear interfaces for the applications. So what are we providing to the users so that they can deploy their applications onto it and monitor it and run it and so on. And then we also have to think about interfaces to other capabilities. So something like logging, say, how do we make sure that somebody, if we're building we've got one team working on our Kubernetes cluster, that it integrates, how do you plug the logging into it? And how do you build the things on each side? Even if it's one team that owns the infrastructure, by the way, even if your organization is a little bit smaller, you still have to think about, you would like these things to be loosely coupled so that you can make a change to your logging without necessarily having to also change your Kubernetes cluster, and vice versa. You want to decouple those changes. And for actually implementing a capability, the way we do this is with infrastructure stacks. And so this is a way of further dividing down how we actually build and deploy and manage our infrastructure code. So an infrastructure stack is a collection of infrastructure resources that are defined and provisioned and modified as a unit. So in short, it's basically, it's an infrastructure project, like a Terraform project that has a state file, or a CloudFormation stack, or what have you. Whatever the tool is and whatever the cloud platform you're using is, the idea is that this is the piece that you can change and deploy a change to on its own. And so you have your stack code, which is your project. You run the stack tool, which say the Terraform command, which reads the stack code, interfaces with the cloud API, and then creates or changes an instance of infrastructure out there, which we call a stack. So just to kind of step back a moment and say, if we're going to try to break down the system that we're building into smaller units of infrastructure code, what about code modules? Isn't this fine, right? So you have Terraform modules, and most other tools have some way of making kind of code libraries. Well, modules are useful to compose and share and reuse code, but they're not an independent unit for delivering changes, right? So you still end up bringing, so as an example, I worked with a client here in London where they had a very, very large Terraform project that would take them about an hour or more when they ran Terraform Apply to provision a new instance of this stuff. And so it was a very big project. And the first thing that they were thinking was, we'll just break it down into modules. But the thing is, when you run Terraform Apply, it's going to still read all those modules in and still take over an hour to apply. So it doesn't solve that problem of the kind of deployment unit, making that kind of smaller and easier to manage on its own. So the infrastructure project as a deployment unit is interesting, because the next thing that we can do with it is we can say, we're going to take a project which defines a stack. So let's say it's that Kubernetes cluster, or let's say it's a pool of worker nodes for our Kubernetes cluster, right? We've defined a Terraform project to do that. We can use that same project to create multiple stack instances. And that's maybe because we want to scale or deploy into different regions, or also for deploying on that kind of path to production, the different environments from dev to QA to production and so on, that we can use the same stack code for that. And this leads into the third and final kind of one of these parts, which is evolutionary infrastructure. What I'm talking about here is the ability to make changes to the infrastructure itself really routine by automating that process. So going back to those 4 key metrics again, which are about change, it's very important on infrastructure projects. So whenever we go in and we're helping to build new infrastructure or kind of transform and update infrastructure, one of the first priorities is to build the capability to deliver changes to the infrastructure itself, right? So, and that's putting in place as I'll talk about, pipelines and testing and those kind of things for our infrastructure code, so that we can make those changes easily and reliably. Now, often what people ask at this point is, well, is it really necessary to, and does it make sense to invest time and energy in automation for making changes to infrastructure code, to automate tests and delivery pipelines and those kind of stuff for infrastructure code? Because don't we just build an environment and then it's done, right? We don't change our environments, we build them and then they're finished, so we don't change them that often. Well, if you think about it, there are a lot of different types of changes that we make to our infrastructure, from small changes like patches and fixes to large changes like upgrading major parts of our systems, say operating systems, Kubernetes cluster versions, databases, and so on. And I think it's that mentality that we have. So those organizations which say we don't need to change our infrastructure that often, so we're not going to invest in this. This is why we see so much pain and struggle, where, for example, there's a lot of technical debt, there's a lot of systems that aren't really patched and up to date. There's systems which are running really old versions of our key software, like those operating systems and application servers and so on. And so what happens is, because we've said we're not going to invest in being able to make changes easily because we don't think we'll make them often, is that we do make them very rarely, and only when it's at the, when it's kind of too late and it becomes very painful. So in other words, it's like we're running a version of our application server which is 10 years old and no longer supported by the vendor, or the vendor's gone out of business or been acquired. Now we have to upgrade, right? You're forced to upgrade in a very critical kind of situation, and it becomes a big project. Everything has to stop. It's a lot of effort in order to do the upgrades. And so this is a self-fulfilling prophecy of saying we're not going to change our infrastructure that much, so we won't invest in being able to. Whereas if you invest in changing in those systems to make it easy to change infrastructure, all of these kind of updates and changes happen routinely as you go along. So patches, when they come out, you get applied. So as an example, one of the classic things is where the CEO of a company reads in a like Wall Street Journal or some kind of business-oriented thing about a new security vulnerability in Linux. And so they, oh my God, we need to make sure that all of our systems are patched. And in most organizations, that means we've got to drop everything, stop what we're working on, make a project plan, and coordinate this big project to roll out the patches across everything. And it's very disruptive and expensive. Whereas if you've got good pipelines, we had this at a project we were working on where this happened. The CIO came in, and so the CEO is shouting because we need to upgrade, we need to do this patches. So please tell us, how long is it going to take? and what's the impact going to be to stopping all the work and everything else so we can do the patches. We said we already did the patch this morning. The patch came out yesterday. Every morning we automatically build new server images, and they're automatically tested, and then we can roll them out using pipelines to make sure that it's very, everything's tested and that isn't disruptive to services. And we do this all the time, regardless of whether a security patch is made it into the Wall Street Journal or not. So it's quite nice to be able to do this stuff. So the question is then, so when we have multiple environments, how do we manage the infrastructure code for those? So back in the old days, when infrastructure as code was very new, we used to have Snowflake servers, and this was this thing where every server from development, test, and staging was built basically manually. Somebody would go in, log in, and run the commands to configure the operating system and install packages. And then things would change over time because somebody replaces the staging server and they've updated, they've installed it with a later version of the operating system, and so now it's a bit different. Or somebody made a fix to one system that they didn't make to the others, and so on. So you get all these differences. We talked about Snowflake servers, and we're going to have infrastructure as code would mean that we can have consistency of all of our servers so they're all the same. Now that we're working at this level with infrastructure, what often happens, what many teams do, is what we can call Snowflakes as code, which is they've got infrastructure code for each of their environments, but it's a separate copy of the code for each environment. And then they make those changes to different copies of the code. So they go and they make a fix on the production infrastructure code and they apply it to production, but they don't make the fix in the other copies. Or they have differences. Production needs to be larger. The cluster size for our Kubernetes cluster needs to have more worker nodes than we have in test. So we'll just make the change there. And even though the idea is that we'll make a change to our infrastructure code and we'll copy it from one environment to the next, that process of copying it from one to the next, you have to do a manual process to copy it. You have to look and make sure to edit the things. Everywhere it says staging, we need to change it so it says production. Don't forget to change the number of the cluster size. Otherwise, we'll cut the cluster down when we run Terraform apply, and suddenly it will crash because we don't have enough servers running because we forgot that we have to have a different number in production. So this is not a great way to do it. People will implement this sometimes with folder structures. They'll have a different folder, and each environment has its own folder with its own copy of the code in there. Or sometimes people do it with branches. So we'll have a different branch for each environment, and we'll merge changes from one to the next. It's not that it's a bad idea to have branches and have your code in source control for the environments like this. It's having it different. It's having the idea that we have to merge the code from one environment to the next and then make changes to it in order to adapt it for the environment. So the way that we really have to do it is following the ideas of continuous delivery for software, which is we promote our stack code across the environments without changing it. So if we need to make a change to our code, if we find a problem in production, we don't change it to a code for production, we change it to the code in the trunk, and then we apply it to development and then to test and staging in production, and we run the tests so that we know that every change has been fully tested. And in those situations where we do have differences between environments, we pull that out into configuration. So we have things like configuration parameters, which we inject in, so we can have a minimum size and maximum size for our number of worker nodes in our Kubernetes cluster, so that we can set those differently for each environment. And those are explicitly pulled out and managed, as opposed to being in code that we have to be very careful when we edit. And then we can use pipelines to deliver the changes to our infrastructure code, so that we can automate the process, so that it's centralized. We're not running a Terraform command or a CloudFormation command from our laptop or our workstation. It's being done in the pipeline, so it's in a managed way and controlled and automated, and all these kinds of things. So exactly like we do for our application code, we want to do that for our infrastructure code as well. And then the next kind of step is these different stacks and these different capabilities. We want to be able to deliver and test them separately. So we want to make sure that we've managed the dependencies between them to keep them in a way that keeps them loosely coupled, so that we can test each piece on its own without having to stand up an instance of the full set of infrastructure in order to test one little thing that we're working on. And so there's a lot that goes into making that work. So that's it. Those are the three pillars of scalable infrastructure. I will have a look at the questions now. If you've put questions into the Q&A app, or they can also go into the chat as well. Somebody's asked about the recording is going to be uploaded in the slides as well. I will share in the same way. Yeah, I don't see any questions in the thing yet, but
I have one if I can.
okay.
How do you feel about introducing security and security aspects through all of this? Like, do you consider it like through the tests? Do you consider it before? Like, how are the security aspects introduced in all this approach?
Yeah, it should be throughout, really, right? I mean, first of all, we need to, there's the educational part, so making sure that people who are working on infrastructure code as well as applications fully understand and have that kind of responsibility to make sure, okay, I know what needs to be done and what's required. And then, putting tests in, so writing, compliance as code, security as code, where you have tests that you put into your pipelines, which tell you. And I think the really useful thing about that is that then empowers teams, right? So the traditional approach with infrastructure is let's say load balancer or firewall rules. Well, developers can't touch those, right? That's really bad to let developers touch, and configure firewalls. Well, actually, if you say, I can change the code, the infrastructure code to open up, say, a new firewall rule for my application that needs it. And then I can push that change, and then we can run the tests to make sure that it's done correctly and properly, and even have approval processes. So you can still have somebody look at a change and say, oh, firewall rule has changed. We need to look at it and approve it in the pipeline. But just the fact that developers are able to kind of make those changes rather than having to ask somebody else to do it who may not understand, because you know this from when we work on projects, right? You get you ask for the security department to make a firewall rule change. They make the rule change, and then it's like, oh, it actually doesn't help. It's not the right thing, and so so I think there's all those aspects. So having the tests to help with security, and still having the points where people can review it. One thing that's useful is to separate out when you're thinking about the design of your infrastructure, is to separate out which parts might have more rigorous requirements. So for example, you say this part of the system is handling credit card numbers, and so it's subject to PCI compliance. So you can say, let's put that in a different stack with a different pipeline so that you can do the extra steps that you might need to approve changes and review them. And then other parts of the system which don't have that, you don't need to have the same rigor for the compliance.
Thank you. We do have a question in the chat if you want to have a look. I actually think I recognize the speaker, the people asking the questions.
Oh, there's the open in the Q&A thing here. Let's see. So there's Ruben Hillier's asked about the architecture pillar. Do you see having modules in anti-pattern? So I think modules can be useful. Again, it's for code reuse and code sharing and organizing your code. It can be useful. I think sometimes it's overdone. So people put code into modules just to kind of organize it, where it actually adds a lot of complexity. Sometimes they have modules and they're separately versioned and so on. So I don't tend to use modules as much as other people might, but I wouldn't consider it an anti-pattern in itself. And so I had a more account. Yeah, I'm not sure. I mean, just in terms of how to use the modules, I mean, I think you would. So obviously, in your stack project, which defines the useful thing, you might have a module which defines a resource as a part of that. But it really depends. I think it's again, you have to kind of think about it. I think it's the same principles that we use for designing, say, libraries for applications. I think about like solid principles for how to design those well. I think that's really important. And what kind of tests we write for infrastructure code. So this is a big subject. So there's things that you can do offline. Things like linters, which just kind of look at the code and tell you things about the code itself, or static code analysis. There's more and more of these things kind of coming out for infrastructure code. Not as much as there are for application code at this point, but so that can be useful. I think having the kind of, I think the shape, the like the pyramid shape that we tend to have for applications isn't as relevant, I think, for infrastructure because it's that unit test level, which often isn't as useful, where you have a bit of code that says, like, say, create a subnet, and then you have a test that says, is the subnet created? You have to think about what the tests are going to actually catch. So normally, if the code doesn't create the subnet, like, it will fail. The tool will fail. And so you'll never get to the point of running the test. And so most of the times when I write tests that are kind of like that, test that the thing was created, most of the times my tests fail, it's because I didn't update the test, right? So the more useful tests are where you have, like, we've got a couple of different pieces of infrastructure code, which then create a thing. And it's not, did the thing get created? It's like, does it do what I think it did? So a good example of the kinds of things I tend to write tests for are, I provision a server, I provision some, I make a security group to allow a connection in, a load balancer to handle the connections, some network routes to kind of set it. So I put these bits of infrastructure, and then I want to have a test like, does it actually work from end to end, from the gateway and the external IP address? Does it actually get in and then talk to my server? Because that's like the messier part, where you write all the code and you think it's okay and it creates all the things, but it doesn't actually do what it needs to do. So I think it's that level of stuff, really. What else we got?
So I'm wondering, Keith, on what you just said, right? So
Yep.
are you then testing the stack? So is that the approach you're suggesting? So looking at like the collection together, like as a
Yeah,
group?
I think you would have the different levels, right? So if you're using modules, for example, you'd probably want to have some tests for the modules. The stack, yeah, I think you want to have some kind of testing around the stack itself. And then you probably have tests where you test the different stacks. So if I've got my, again, that Kubernetes cluster, maybe I have one stack which is creating the worker node pool, another stack for the control plane, another stack for some networking and storage and so on. So maybe we have different stacks for these. So then you kind of want to test, put them together, integration, right? It's okay, this thing should allow me, and you do it based on those contracts, right? Because you say, so the point of this container deployment capability is that as an application team or developer, I can deploy my container onto it, and then it's able to do stuff. And so you test that, and that might even be your test, is like, I have a dummy, simple container, I deploy it on there, and like I make a connection request, and yeah, it actually manages to talk to it. And then potentially for the wider scale, I think once you get into the wider scale, you're probably talking about monitoring, really, as a type of testing, or application testing. I mean, that's also a part of it, right? Your application tests will probably tell you something about your infrastructure as well.
Okay. So then if I can summarize just to see whether I understood, right? So when we talk about modules, then we consider some dummy examples of the deployment of the module within the pipeline, so that I know that when I use that module, it does what I expect it to. But the kind of tests are flow based more than anything else. And then try and also leverage the other kind of end-to-end tests that you might have in the system to make sure that you get the two.
Yep.
Okay.
It's kind of like a cumulative integration, really, right? Because you're taking the small pieces, test them on their own, put them together, test them together, and on and on. And when you think about applications and infrastructure together is an integration level, right? So that's kind of a system level test.
And so because we at ThoughtWorks, right, we do talk a lot about TDD, right? In this case, it's rather different. Do you see, so I assume that in this approach, we could potentially miss some of the configuration aspects, or, so if you're focusing on the flow, right, you're not necessarily testing all the aspects. So are you saying that in the flow test, you also cover all the, smaller configuration parts?
I think it depends. You need to think about the risks, right? What are the things that can go wrong? And you kind of want to make sure that each thing is tested at that point. So if it's a smaller kind of thing, then you kind of want to have the test earlier on, where it's making that smaller piece. And then those kind of, as you said, the flow-based, more integration level tests should be testing what do we need to test at this level that we couldn't test on the individual pieces. And then I think when it comes to configuration, so one of the things is when you if things get configuration parameters that you use in your environments, and you want to test those that it's correct, that's where you probably get into things that they might be like, say, smoke tests, where it's like the post deployment, like, is this environment doing what I want? Or it might be monitoring, right? Where you say, like, let's have monitoring on the environment, even a test environment, where we say that, like, it's, it worked correctly and is configured correctly for the usage that we have, so that you don't waste time. Why did my tests fail? My application tests that we ran, well, it's because the environment was not deployed correctly and configured correctly.
Thank you.
There's another question in the
Okay.
Yeah.
How do we know if infrastructure code is tested? So a lot of this infra code is configuration, doesn't necessarily generate some kind of an artifact. So I think you have to think about, how are you promoting your code across the environment. So it might not be an artifact. A lot of times it is, right? So a lot of times on projects I work on, I'll like take my, say, Terraform code and I'll put it into a tar file, and I'll give it a version number, and I'll put it in maybe an S3 bucket or a repository of some kind. And Vanessa's smiling because we did this on our project, right? And so you treat it just like an application artifact. So that's one way. Or even if you are using, say, branches, and as you copy code from one branch to the next, you should have the process for progressing your code from one environment to the next, your infrastructure code from one environment to the next, should be an automated process that should run the tests and should refuse to promote the code to the following environment if the tests fail. And so that's how you know that it's tested. But it is important to kind of think about, how do you look at the versions of your infrastructure code and promote it in a way that you understand the versions of code, whether that's putting a version number on an archive file, or whether it's with branches which indicate how code has progressed.
So I have a question. When you talked about like the different code for different environments, and you're seeing this as an anti-pattern, because then you would have to apply the same fixes in different environments. There's something that I've seen done many times, to use different branches of a Git repository to store different configurations from different environments. Mm-hmm. And it kind of seems strange to me at first, at least. Would you recommend to have like everything on the trunk, maybe, I don't know, different layout of folders, or some clever way to actually propagate a change easily to most environments? Or what is it? Do you have any practical suggestions?
I think it depends on whether we're talking about the infrastructure code. So a lot of times I think with infrastructure code, we tend to kind of combine them conceptually, and assume we talk about infrastructure configuration code, whatever. But I think there's the codes. But I'm not talking about the code. I'm talking about, this is the stuff that would be moved unchanged from one environment to the next. And so that's where, how you do that. Again, you might put it into a zip file or something with a version number and put it in a repository, and then make a new version, every time with a new version number. Or you might do it in branches, and you replace the branch. It's not just about merging, because you don't want to leave stuff from the old branch if you've deleted it in the code, right? But it's like replacing the branch. I think that can be okay, as long as you're, again, not making changes to what's in the individual branches. Then there's the configuration, which are the things that actually do need to be different between the environments. So I use the example of the cluster sizes, and there's different patterns. I talk about in the book different patterns for how to do that. So one thing I've done a fair bit is just to have a folder with a different file, like a properties file, or a TFVARS file for Terraform. I use Terraform a lot, so that's why I talk about it a lot. But it's that each environment has that file that you read in. And I would tend to bundle that up wherever the code is itself, if you're using it in a folder. But then you can also do branches in Git of just the configuration. So you have your Git configuration repository. Maybe there's a different branch for each. Although for configuration, I would tend to think it might be better for that to be folders rather than branches, because it's meant to be a different thing. Like branches are for versions, right? It's the same thing, but different versions. I would tend to put it in folders. Also, like a configuration registry can be a useful place to put it. So, a key value store or something like that. You might consider doing something like that.
Thank you.
think there is another question
How to
in the
prevent
chat.
a developer of the team unintentionally running a pipeline that changes or migrates infrastructure, say to apply changes by the command line. I would say the opposite. So like, I mean, the command line, you have no control over, no visibility. So what happens is somebody applies changes from the command line, they have the code locally, and then you don't know that they've done it, what version of the code they've used. So I've been on a team where people spent the whole day like, oh, you know, something's really wrong with the, you know, this environment. Like I made this change and then it's disappeared, and like other stuff is appearing, and like people are like, yeah, I've seen the same thing. What is going on with this environment? Things are disappearing. And it's because they're both applying code from their laptops, you know, their own versions of the code from the laptops and overriding each other's changes. So like CLI, I would not consider safe for any environment that's shared. If you're working on your own instance because you're testing a change to your code, running it, that's fine. But like any kind of shared environment should be run from a pipeline. And how do you control that? Well, the pipeline, you know, whatever tool you use for that should, you know, give you the control, whether it's like authentication, requiring people to authenticate in order to run the pipeline. But also the pipeline shouldn't, you know, it should only run the changes of like the code that's been promoted. So it shouldn't really be possible for somebody to use the pipeline to apply some arbitrary code to your infrastructure. So it should be the pipeline stage for the QA environment should always apply the code that is the current version of code for QA. And then you have a promotion stage where you promote from the dev environment to the QA by changing which artifact is the QA one now, which version should be deployed to QA. So your pipeline should give you the control that I don't think you do have from the command line.
Talking about pipelines, how do you suggest we sync, you know, our various infrastructure pipelines and our services kind of pipelines? So I assume that there are changes that, you know, sometimes require regeneration of components and so on. So they might have an impact on each other, right? And when you talk also about promotion, there is, and potentially also to test all integrated together, I see relationships between pipelines. How do you suggest we deal with that?
So yeah, so I mean, you can have that like massive test environment with all the things. Those often become bottlenecks. There's a couple different ways to do it. It depends on how shared, I guess, the ultimate environment is. So if it's like, if production is like, you know, the infrastructure code, you're creating the Kubernetes cluster, say, and then you want to test the applications and services that get deployed into it, you might have a pre-production instance where you deploy the services and run the tests first before the infrastructure code gets moved along. Or you might have it where, particularly as things scale up, you have, so one team might have their own Kubernetes cluster where they deploy their multiple services and applications onto, or one group of a couple of teams might. And so you can then just do the integration testing at that level. So just to give an example, let's say you have 3 or 4 different product groups, each of which has 2 or 3 different teams working on different services for each of their products. Each of those product groups might have an environment where and they might each have their own cluster for the products, and then they can pull in the infrastructure code when they're ready, right? So a team that maintains, here's the Kubernetes cluster code or that container deployment capability, might say we've released a new version of that, we've tested it, and now that version is now available, and then the other teams can kind of pull it in and run the tests on it when they're ready to. So it becomes more of a pull-based for them, so that they can do it on their own schedule. And that also helps, rather than forcing, say, an update to Kubernetes across all of the infrastructure and across all the teams, where you then have to coordinate. We're not ready for it yet. Can you wait? Oh, we need it now. Blah blah blah. You kind of have the independence to say, oh, we need it now. We can pull it now. You pull it when you're ready. Some different thoughts on that.
Thank you. So if there are no more questions, we have the last 5 minutes. I want to thank Kief for the great talk from, me, Ronnie and Mario and Shano, the other admin of this community. And thank everybody who have joined the talk today. Today is the 6th event of ShareIT, so we're still a new community, but it's going strong. We will soon publish, or we're trying to build a larger calendar for next year. So we'll get in touch with new events and you can follow us through the meetup. This talk will be uploaded to YouTube, and also Kief has agreed to share the slides, so we will be able to share that with YouTube. You'll probably also get a feedback form. So if you want to give us any feedback on the talk, we'll also be happy to share it back to Kief. So thank you again, everyone, and I'll see you next time.
Thanks all.
Bye.